SAP 1 ERP Central Finance. Abstract Central Finance, CFIN, is an SAP-provided solution to plan and implement a roadmap for migrating legacy ERP systems into S/4HANA with minimal disruption to the legacy financial systems. Documents posted in source systems are replicated into S/4HANA and posted to the S/4HANA ledger after transforming the source system data to a common data format. By standardizing data into a common format, CFIN enables cross-system functions like allocations, segmentation, and consolidations in S/4HANA and paves the way for migrating month-end and year-end book close from source systems to S/4HANA. This white paper covers the technical and functional aspects of the CFIN implementation. In this document we will cover details of the integration between non-SAP, legacy SAP, ECC, SAP Landscape Transformation, SLT, Master Data Governance, MDG, and SAP S/4HANA systems. 1. Introduction. Like large enterprises has complex financial systems, multiple SAP and non-SAP for different business functions. To reduce redundant processes and to simplify our period-end closing process, we emerged with our own strategy, which is elucidated in the journal, and implemented the central finance solution of 1 ERP by referencing the mentioned references. We embarked on a multi-year journey to consolidate all legacy ERPs into S/4HANA. As a first step of our ERP consolidation journey, we implemented CFIN to replicate posted financial documents from non-SAP and SAP ECC systems to S/4HANA using the SAP Landscape Transformation, SLT, replication server. CFIN standard functionality is utilized to transform replicated documents to a common format using key mapping, account, profit center, cost center, etc., and value mapping, company code, document type, posting key, etc. CFIN performs all applicable FI substitutions and validations, and posts error-free documents to the S/4HANA ledger. Any issues encountered during mappings or validations are flagged as an error and managed by SAP's Application Interface Framework, AIF, where mapping/validation issues can be corrected, and the data can be reprocessed. SAP Central Finance Architecture. Figure 1 illustrates the architecture of the CFIN implementation. We have two SAP ECC systems as source systems shown in architecture diagram, and PeopleSoft 9.1, PeopleSoft 9.0, Oracle and CostPoint are non-SAP source systems. The SLT replication server and MDG systems are standalone. The MDG system, also an S/4HANA system, is used for master data and key mappings. The legacy SAP ECC applications are connected directly to S/4HANA via the SLT. Since SAP does not support or provide any tools to connect non-SAP systems directly or via the SLT, we developed a custom solution, which is outlined in Section 2. Figure 1, Architecture of Central Finance. Diagram. Description automatically generated. 2 Integrations of SAP and non-SAP systems. In this section we will walk through the integration of SAP and non-SAP systems with S/4HANA. Note that extensive knowledge of the source system data and how it is structured is required to build a plan for extracting and transforming the data, and to achieve a successful integration. SAP systems. SAP Landscape Transformation, SLT, is an existing tool used extensively for replicating data from SAP/Oracle applications to SAP HANA at the database level. In this section we will cover how we can utilize SLT to replicate posted financial documents. 1. To enable financial document replication, it is very important to enable the content in SAP SLT with which S/4HANA and SAP ECC application can communicate, and that is possible only if you have the understanding of SAP No. 215-4420. Apply the latest content of No. 215-4420 according to your release of the system, and always have the latest copy of this note. C:\/users\78\desktop\unnamed 1.png. Figure 2, Connectivity from SAP ECC to S/4HANA. We have created separate MTIDs for SAP ECC application to replicate documents to S4. Also, once you upload the latest SAP content, that content needs to be generated in master workbench transaction. Please refer the below screenshot for SAP ECC to S4 MTID configuration. Similar way we completed the setup of other ECC system. Figure 3, MTID setup from SAP ECC to S4. So once the MWB objects are generated, structural relationship will be defined, and mapping will be done. Figure 4, structural relations SAP application. After enabling replication on the SAP source systems, header details of the posted/changed documents are captured on the delivered CFIN replication trigger table CFIN_UCT. As soon as a document header is posted to the trigger table, SLT extracts the details of the document and pushes them to S/4HANA. The required configuration and MDG connectivity for CFIN is maintained on the target system, S/4HANA, using transaction code CFIN. CFIN utilizes fins_CFIN_AC_interface BADI to process incoming documents from the source SAP systems. There are 4 major steps in the BADI. 1. Prepare_input_data, prepares incoming data before applying transformations. This method customized to include custom fields. 2. Map_values, both key and value mappings executed in this step. MDG utilized for key mapping and value mapping are based on vmimg. Customized to include custom fields. 3. Adjust_posting_data, executes final adjustments to the data before calling post step. Customized to apply specific default logic, S, and to handle rounding issues between source and target currency code definitions. 4. Call_AC_interface, calls delivered accounting document creation interface to post transformed data from step #1 through 3. Key mapping values are maintained in MDG and value mappings are maintained in the target system using transaction code vmimg by each logical system, source system. AVE is a framework to implement and monitor application interfaces. As part of CFIN implementation, SAP delivers standard AVE interfaces for managing CFIN replication 2-3. We utilized SAP delivered interface IDs AC_doc and AC_doc_change for SAP source systems and AC_doc_x for non-SAP source systems. Errors from CFIN replication can be monitored and reprocessed by using /AVE/IFMAN or /AVE/error codes. Non-SAP systems. The most interesting topic we found in Central Finance is the integration of the non-SAP application with S/4HANA. It is quite challenging to configure the non-SAP application with S/4HANA, as it involves lot of customizing. We are replicating documents from non-SAP applications like PeopleSoft 9.1 and 9.0, Oracle and CostPoint. We created custom programs, tables, and used advanced replication options to replicate posted documents from all non-SAP applications. After replicating posted documents to custom SLT tables, we used custom modules and standard SAP functionality to replicate documents to S4. For more details, please refer SAP Note 248-1900. This SAP note keeps on changing, so we recommend to use the latest copy of this note. Figure 5 illustrate the data flow from non-SAP application to S4, e.g. PeopleSoft 9.1. Figure 5, connectivity from non-SAP to SAP S/4. Below diagram illustrate the MTID configuration of non-SAP application, e.g. PeopleSoft 9.1. Figure 6, MTID setup from non-SAP to S4. To replicate the data from non-SAP application to SLT, advanced replication feature plays the most important part. So we created custom functions to map and filter data from source system tables to customs tables on SLT. Figure 7, mapping of the non-SAP table with custom programs. A custom program scheduled to run every few minutes to process data on Z tables and performs following 4 major functions. 1 splits PeopleSoft 9.1 documents into multiple SAP documents based on the multiple PeopleSoft fields used for S/4 HANA company code derivation. 2 split each document from step number 1 into multiple documents if the total number of lines in the document is more than 900 lines. 3 generate a unique object key for each replicated S/4 HANA document to enable duplicate identification in AIF. 4 map PeopleSoft field values to SAP fields and post the processed data to the CFIN SAP SLT tables, /1LT/CF_E_header, /1LT/CF_E_ACCT and /1LT/CF_E_EXT_IT. The delivered /1LT/CF_E_header table acts as a trigger for the non-SAP system's replication. As soon as a header record is posted to the table, SLT pushes document details to S/4 HANA. Like SAP replication, external system documents received from SLT go through key and value mapping and standard FI substitutions and validations before posting to S/4 HANA. Any documents with mapping or validation issues/errors are managed in AIF. To manage our Z tables volumes, enable manual intervention for production issues, and facilitate testing, several utility programs were created allowing the team to upload data, archive data to backup tables, and delete data from the Z tables. Figure 8, File-based replication from non-SAP to S/4. PeopleSoft 9.1 replication was a big challenge for our team as we had to deal with large volumes of data, 80 M+ line items per month. By design, PeopleSoft stores more details on line item tables, PS_JRNL_header and PS_JRNL_LN, compared to the ledger table, PS_ledger, and to replicate necessary line item details we choose to tap into the PS_JRNL_header and PS_JRNL_LN tables as our source for replication. But PeopleSoft uses the same line item tables for storing all journals, documents, including journals in progress, awaiting for approval, awaiting for posting, posted, etc. This resulted in an additional challenge to filter data at the source system to pass only posted documents to SLT, especially the PS_JRNL_LN table, as it does not have a field to identify posted journals. Our source system database administrators built a custom process to filter and pass only posted journals to SLT. One more challenge we faced with PeopleSoft 9.1 is the performance impact on the source system, especially during month-end processing. We leveraged Oracle Golden Gate technology to address performance issues on the source system. Instead of tapping PeopleSoft 9.1 tables directly, we replicated data from PeopleSoft 9.1 to Golden Gate and utilized Golden Gate tables as input to SLT replication. Another one of our non-SAP systems, CostPoint, uses replication like PeopleSoft 9.1. Both are real-time replications. Replication of data from two other non-SAP source systems, Oracle and PeopleSoft 9.0, is similar to PeopleSoft 9.1, but instead of using real-time replication we utilize file-based interfaces. As soon as an interface file arrives on the SLT file system from a source system, a custom process kicks off in SLT to read and process the file. Basic functionality is similar to the PeopleSoft 9.1 custom process. Documents from the source system will be split into multiple SAP documents by number of lines, map PeopleSoft 9.0/Oracle fields to SAP fields, generate unique object keys for identifying duplicates for each document and post data to the /1LT tables. Data flow after posting data to the /1LT tables is exactly the same as PeopleSoft 9.1 replication. Figure 4 illustrates the non-SAP replication including the file transfer and the mapping of FI documents on the S/4 HANA side. Depending on the replication volume, architecture of the source system and network landscape, we utilized different integration methods for different external systems. PeopleSoft 9.1 and CostPoint are real-time integration using SLT, whereas Oracle and PeopleSoft 9.0 are file-based interfaces. To ensure data integrity, we added additional controls in the custom modules to identify duplicate journals/documents for real-time integration and to identify duplicate files for file-based integration. By doing so, we were able to catch and eliminate duplicate errors before AIF, and also added additional file-based interface controls to identify missing files. Performance optimization. Another challenge which we faced was to optimize the performance of the replication. Our business team has certain slots for the replication of documents. The number of documents replication from SAP application and non-SAP legacy systems are huge, so to meet those slots we turned on the parallelism in advance replication feature, with which can replicate the documents within the defined slots. There is no simple formula which can fine-tune the overall replications. It's an effort of days with which we can reach to that point where we can meet the overall SLAs. Balanced access plans with parallelism on the table under replication for non-SAP system. One more area we concentrated on for performance tuning was custom processes on SLT to map legacy values to standard SLT replication tables. We designed all custom processes by unique key utilized in the source system. For example, custom process for PeopleSoft 9.1 is designed to process journals by PeopleSoft business unit and journal date. By doing so, we were able to schedule parallel jobs to run concurrently and process data for multiple business units simultaneously without looking any time during close window. Figure 9, Replication of documents within SLA. Figure 10, Parallelism on the access plan and table replication. Upgrade strategy. We started one ERP project on 1709 S4 release on HEC and SLT with DMIS on 2013 on Sybase database. Then we migrated our production landscape from HEC to on-premise, and database migrated from Sybase to HANA 2.0, and this was a big change in our landscape. Using standard SAP provided R3 load tool, we migrated production data of SLT to HANA 2.0. As mentioned above, in SAP system and non-SAP system, we upgraded the latest content to 1909. Key challenges which we faced after the upgrade and migration was the data type for logging table got changed, and we had to regenerate the runtime object and workbench objects. Also, with that we have to upgrade the DMIS add-ons in the source SAP systems. 3. Reconciliation. Apart from the complicated PeopleSoft 9.1 integration, the biggest challenge we faced was data reconciliation. Our main objectives for the CFIN integration were to meet SLAs for replication timings, and data integrity. Data posted in the source system should tie with data posted in S/4HANA with minimum or no manual intervention. We utilized a different reconciliation approach for SAP and non-SAP source systems. Reconciling data for SAP source systems is simple and straightforward. Out of the box, SAP provides 2 reports to compare data between source and target systems and report any missing data. fins_CFIN_DFB_FI_number, reconciles data at documents level and provides details of documents in source, documents in AIF with error, documents in AIF without error, and documents not in CFIN, missing. fins_CFIN_DFB_FI_BAL, provides details of G/L balances between source systems, AIF, and S/4HANA ledger. Reconciling data for non-SAP systems is more challenging. Out of the box, SAP does not provide any utility/tool to reconcile data for non-SAP source systems. We leveraged BODS to build custom reports to reconcile data between SLT and source system tables and report any discrepancies. By using BODS, we were able to directly connect and query source system and SLT tables, which is much efficient than building a custom SAP reports on SLT to directly query source system tables. BODS reports are just one piece of the puzzle. They ensure that all the data posted in the source system replicates successfully to SLT standard tables. The second piece of the puzzle is data reconciliation between SLT standard tables and S/4HANA. We built a second custom process to do this validation. A simple program to compare data between the /1lt/cf_e_header table and the S/4HANA AVE tables to make sure that all documents replicated to S/4HANA and to verify that there are no duplicates in S/4HANA by object key. This ensures that none of the source documents are missed in replication or posted twice in the target system. The reconciliation process for both SAP and non-SAP systems is automated and scheduled to run multiple times a day to report any discrepancies as soon as possible. Conclusion. In order to enable large enterprises with multiple legacy financial systems to accelerate their migration to S/4HANA with minimal disruption to the existing systems, they must choose the best integration option to ensure success of the CFIN project. Some of the key aspects the team should consider before deciding on the type of integration includes: how much data is being replicated? How soon do you need data in target systems? Can legacy systems support the type of integration? Does it cause any performance issues on the source system?